Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refath Bari, aka 800/800 guy, is teaching calculus this year. Watch his videos.
Alright folks, what's up? Welcome to another episode in our calculus series. Today I'm going to be showing you guys how to prove that one set is equal to another. So let's take a look at the question. So we're told that we have two sets, right? Sets A and B. And we know that set A is a subset of set B. What else do we know? A is a subset of B and B is a subset of the domain of a function f. Right. So now what can we do using this information? Well, we're asked the following question. We have to prove that if A is a subset of B and B is a subset of the domain of a function f, then f of A must be a subset of f of B. Alright, so that's part one of our question. How about part two? For part two, what we have to do is prove that, well, we're asked if A is a proper subset of B, proper has no bar on the bottom. If set A is a proper subset of set B, then is f of A a proper subset of f of B. Alright, so let's take it step by step. Let's start with part one of question one. We have to prove that given these two conditions, given that set A is a subset of set B, and given that B is a subset of the domain of a function f, can we prove that f of A must be a subset of f of B? Well, as a matter of fact, these questions they're kind of hard to prove analytically, so I'm going to try to take a sort of visual approach. So let me show you what I mean. How do we visualize functions? Well, functions, I tend to think of functions as kind of ovals, right? Ovals that contain sets, right? So let's say this is the domain of function f. And every function has a codomain, right? A set of allowed values. So this is the codomain of our function f. So we have our domain and we have our codomain. What else do we have? We know that there's a set B that's an element of the domain of f. So let's draw in this set B. Alright, good. We also know there's another set A, that's an element of set B. So let's draw that in. Alright, perfect. So if you can see, we have the domain of f, which contains the set B, which contains set A. Now you're probably thinking, alright, now I'm stuck. What am I gonna do? Well, when you're stuck, try to think of definitions, right? Like, try to think of the most basic of the basics. Right? What is a function? A function is like a machine. It takes one thing and spits out another. In more formal notation, a function f takes set A and transforms all the elements of set A into f of A. Sounds simple enough, but how do we represent that? Well, let's take a look. We have set B. When we put it through this machine, this function f, we're going to get the output f of B. So far so good, right? We'll do the same thing with A. We take it through the machine f, we get the result f of A. Alright? And now, we've just visually kind of pseudo-proved this conjecture, right? That f of A must be a subset of f of B. But now let's try to do it the hard way, the analytical, the gritty way. So how do we do that? Well, let's take it step by step. Let's start with our givens, shall we? We know that A is an element of B. A is a subset of set B. So let me write that down. So A is a subset of set B. Now I know that A has a bunch of elements, right? So let's say that I represent one of those elements with the variable x. Right, so let's just say that there's an element x inside this set A. Well, I can represent that by saying that x is an element of A. Right, so far so good. Now if x is an element of A, it also has to be an element of B. Why? Because as I said, A is a subset of B. So thus we can conclude that therefore X must also be an element of B. Now, what else can we say? We know that B is in the domain of F. B is a subset of the domain of F. And thus, F of B must be a subset of the codomain of F. Right? So far so good. Now because F of B is a subset of the domain of F, and we know X is an element of A, what can we take this? Well, because X is an element of A, F of X must be an element of F of A, by definition. And by the same definition, because we know that X is an element of B, F of X, once again, must be an element of F of B. And now we can finally strike gold. Because F of X is an element of F of A, and because F of X is an element of F of B, we can conclude that F of A must be an element of F of B. Oh, that doesn't look like a B. That looks like a B. Alright folks, so we've, let me box that in. Horrible box, but it gets the job done. So yeah, that's we've just proved our first set theory statement, and we're done with the first part of this question.
The Bari Science Lab to fall in love with math and science, especially programming.